to explain with more detail. So consider method triangle from class triangle type on the book website. As you see, we have defined the enumeration type triangle as four types. You have seen scalene triangle, isosceles triangle, equilateral triangle, or invalid triangle. And you know each of these types. In this type, it may be we have some sides of length negative, or the sum of two sides could be less than the third side. In the equilateral triangle, all sides of the triangle should be same, should have same value. Okay. Or in the isosceles triangle, two of sides are the same. And in a scalene triangle, there is no relationship between the equality relationship between each pair of sides of triangle. Okay. So we have defined a method triangle and their sides as input parameters. Let me use interface-based approach. As I said, we should treat mechanically with these parameters. This means that we consider each parameter in isolation. So the only characteristics we could use to partition the domain of these parameters, these integer parameters, is the relationship of values with 0. So for partitioning in this approach, we could just consider this characteristic, the relationship of side with 0. So for this parameter, we have 3 blocks, and so for this parameter and this parameter. Okay, we have 3 blocks, negative, positive, and 0. Okay. Excuse me, let me consider all partitions could be considered in this approach. So as you know, 3 blocks could be considered for each parameter. So altogether, the all blocks we should consider to test this method is 3 cross product with the blocks, the total blocks for this parameter. It's also 3, and this is 3. So 3 times 3 times 3 blocks could be defined to choose our input values. Okay. But when we use functionality-based approach, we should consider the relationship, the semantic, the meaning of each parameter, and the functionality of the method. As you know, the functionality of this method is to detect the type of the triangle. So the prominent characteristic in functionality-based approach is the type of the triangle. And when we know the functionality, we could design different test cases. We could design a test case in which the input triangle is scaling. We could define one test case for invalid triangle. We could define one test case for equilateral triangle. So we could simply say this approach is blindly testing. We don't consider any semantic about the input parameters or about the functionality of the method. But in functionality phase, we consider all of these possibilities. We identify characteristics that correspond to the intended functionality. As you know, we have defined this method to detect the type of a triangle. But in previous approach, the triangle is not considered at all in designing test cases. The definition of triangles, the principle of triangles are not considered at all. And we don't know which are these parameters. What is these parameters? Okay. So in this approach, in the functionality-based approach, as I want to consider some more semantics, more functionalities, we require more design efforts, and we can incorporate domain experts, and we should have some semantic knowledge. We can use the relationship of the input parameters, and we could model the domain based on requirement document, based on the specification of the software product or of the program. Okay, and necessarily there is no implementation access. Okay, in this approach, the same parameter may appear in multiple characteristics. As you know, for checking the equilateral triangle and the isosceles triangle, we should consider each pairs of our input parameters, or sides of the triangle. So it is harder to translate values in test cases. Okay. Excuse me. Again, we consider the method triangle in triangle type class. As you know, we have three parameters that represent the sides of a triangle, and for modeling the domain, the only characteristics should be considered in this approach is the type of triangle. And you know, we have 4 types of triangle. A good test set in this approach is a test set that consists at least 4 test cases. One test case which is scaling triangle, one for isosceles triangle, one for equilateral triangle, and one invalid combination. So we remember the step 1 and step the 5 steps in this approach to see what are the duty of testers in each step. The step 1, as you remember, in the step 1 we should detect all testable functions. So this is trivial for all programs. And in step 2 we should define all parameters, input parameters, not inputs of all methods, but it contains all shared variables, all state variables, all database files, or other external files that could be read in the program as input parameters. So this step is more creative engineering step. More characteristics in this approach means more tests. When we consider more characteristics of our program, we should design more tests. In interface-based approach, we should translate parameters to characteristics. For example, for an integer parameter, we consider the relation to 0. For character values, we consider the case of letters. For Boolean parameters, we consider the true or false parameters. So candidates for characteristics in interface-based approach considered for functionality-based. For functionality-based approach, we should consider the preconditions and post-conditions of our method, or relationships among input parameters or input variables, the relationship of variables with special values, as I said in interface-based. In these 2 steps, we should not necessarily use the program source. This means we have not access to the body of our methods, but we have the definition, the interface of our methods. We need to use the definitions of our interfaces or of class interfaces, but there is no need to any details of the body of each method. So in this chapter, we just use the definition of interfaces and the functionality, the description of the functionality of program methods. This item said that it's better to have more characteristics with few blocks, but when we have more characteristics with more blocks, we should define more tests, because we should define in the best situation all combinations of all blocks, and it could be impossible for big programs. And in the next session, we will talk about some coverage criteria to limit the test cases to fewer tests. Okay. As another example, please note to this simple method which tries to find an element from a list. We search an object into a list, and this simple element return a Boolean value, which if the list or element is null, it should throw null pointer exception, as you have seen before in previous chapters. Else return true if element is in the list. If we have an occurrence of the element in the list, we should return true, but otherwise we should return false. This is a simple description for this simple method. This is all information we need about one method. We need to design test case in this chapter for this simple method, and there is no the body of this method. There is no need to have the source code. Okay, we could use both approaches, interface approach and functionality based approach, according to this given knowledge. Okay, let me see. In interface approach, we consider each of these two parameters in isolation. For example, we consider the list parameter in isolation and partition the domain of the lists in isolation. For example, we could define some partitions for lists. We could define a block which consists of a list, a null list, or a list with 0 element, an empty list. Or we could define a block with lists with more than one element. Okay, so we consider several characteristics. We could consider several characteristics for this parameter. The first characteristic is the null characteristic. When we use these characteristics for partition the domain, we could have just two blocks by this characteristic. The block 1 define a simple null list, a set with a one instance of lists, which is a null list. But block 2 could have several instances of lists which are not null. So by this characteristic we could partition our domain into two blocks. The second characteristic could be considered. The second characteristic that could be considered in this approach is the empty characteristic. We could define an empty list and a non-empty list. If this characteristic is true, we have simple an empty list. So the block 1 consists just one list, which is an empty list. But block 2 could have many instances of any arbitrary list with any length, with any number of objects. So in this example, we just consider the first parameter in our partitioning. Also, we could consider the second parameter in isolation. For example, the second parameter also could be null. If the second parameter is an integer value, we could consider the relationship of this parameter with 0 or any other data types in any other data types as we can define. So in interface-based approach, we just consider characteristics which are special to any parameter in isolation. But in functionality-based approach, we consider the functionality of the method. The functionality of the method is defined by the preconditions, by postconditions, by the relationship of its parameters, okay, by the semantic of its parameters, and so on. So in this approach, we have two parameters, list and element, but as we know, the functionality of this method is to search an element within a list. As we know this functionality, our view is different from previous approach. In the previous approach, we have no knowledge about this method. We could not use these descriptions about the functionality of the method. But in functionality based, we zoom in these descriptions, and we should consider the functionality of the method. So in this approach, our characteristics could be as these characteristics. The first characteristic could be the number of occurrences of an element in the list. The occurrences of an element could be 0, in which an element is not located in the list, or could be 1 when we have only one occurrences of the element in the list, and more than one for several occurrences element in the list. So this could be a notable characteristics when we know about the functionality of the method. But when we don't know about this method, we don't know about the relationship of these two parameters. So if we know the functionality, we could consider some more meaningful characteristics to partition our domain, to model our domain. There are some other characteristics could be considered in test of this method. Another characteristics could be this: the element we search in the list could occur in first position of the list or not. As you know, as you have seen in chapter 2, one fault could be in the for loop of our search algorithm, of our sequential search algorithm, as you have seen in a simple example in chapter 2. We start to scan our elements from position 1, not position 0 for Java programs. So when we know that this method is a search method, we should test the boundary positions, such as the location 0, the 0 index of the array, and the last index of the array. So one characteristic in this approach could be the place of the element in the list. We should check the first position of the list, first index of the list, and we should check the last index of the list. There are two critical positions in searching methods: first position and last position. So according to these characteristics, we have 2 blocks for each characteristic. When this characteristic is considered for partitioning, we have 2 partitions. The partitions include a non-empty list. Non-empty list, when this characteristic is true, we should feed this function by a non-empty list in which the element is located in the first position, in the 0 index of the list. And when this characteristic is considered as false, we should define input parameters, we should define a test case in which we have a non-empty list, but the element may be occurrence in other positions, in other locations, not in the first location. And in the third characteristic, the position of the element is also matter. When this characteristic is true, the element should be located in the last position with index n-1, in which n is the length of the list. And when this characteristic considered as false, we should provide a test case in which we have a non-empty list and the element should not be located in the last position. Okay, so these characteristics is completely different from these characteristics. These characteristics could not be considered in interface-based approach, because in interface approach we don't consider any knowledge about any semantics of the functionality of the method or the relationship of its parameters or the semantics of its parameters. So these characteristics could not be considered in this approach. This could be just considered in functionality-based approach. So in the third step of modeling the input domain, we should do the partitioning according to our characteristics we have defined. We should partition our domain into blocks, and the values is very creative engineering step, because our partitions should be disjoint and all of them constitute the domain, our domain. And this step, more blocks means more tests, because we should test a value from each block to assert the correctness of the completeness of our test case. Okay, Partitioning often flows directly from the definition of characteristics. It's trivial. And both steps are done together. Both steps means step 1 and step 2, and should evaluate them separately. Sometimes fewer characteristics can be used with more blocks and vice versa. There should be a trade-off between the number of characteristics and the number of blocks, because more characteristics means more tests, and more blocks also means more tests. So the number of tests that should be generated should be a logical number. More tests, as you know, means more costs to testing, and sometimes it's impossible for large programs. Strategies for identifying values. There are some characteristics, there are some strategies for identifying values of each blocks of our partitions. Could be include a valid value, invalid ones, and special values. For example, in a triangle example, we could define invalid values for any sides of the triangle. Or in interface-based approach, we used a special value, a zero value as a special value. We could use this strategy. We could partition more some blocks. Some blocks could be partitioned with more details, more characteristics. And an important strategy could be this strategy. We could explore boundary values, as you have seen in previous slide. The boundary values for this functionality could be the location of our elements at first position or last position. So the boundary values are important values, and we should select them, we should test them. And besides this, special values or special boundary values, we should consider normal values, such as normal lists with more than one element. Okay. Try balance the number of blocks in each characteristics, as I told before. Check the completeness and disjointness. These two characteristics, these two properties should be held in all modeling domains. Again, suppose the triangle method, and we want to generate test cases in both approaches. We have talked about the interface approach and in a functionality based approach. As I said, the main characteristics for the triangle method, as you know, we have three sides in a triangle. We have three sides as the parameters of this method. The input parameters is side 1, side 2, and side 3. So for in interface-based approach, the prominent characteristics, the important characteristic to partition the domain of each parameter is relationship to zero value. Okay, so the first parameter could have 3 blocks. The second one again have 3 blocks, and this so on for the third parameter. Okay, so altogether the maximum of blocks is equal to 27. Okay, so we could test this method with 27 different tests. All positive values have the same chance to be selected, and so with negative values. Some triangles are valid and some are not valid or invalid, because if any of these sides have a negative or zero value, choose a negative or zero value, or test case define an invalid type of triangle. But in this method, we could not detect any other types of triangle. This means we could not detect scaling triangle, or could not detect before some test cases for equilateral triangle. Okay, so as the last point said, refining the characterization can lead to more tests, because we could consider more characteristics, but in this example there is no need, and we could consider more characterization. For example, we could consider some other special values, such as 1. We could consider another special value equal to 1. In addition to this special value, we could have another special value such as 1. But there is no need, as you will see in this slide. When we use more characteristics, more special values, we could have more tests. Okay, in this partitioning, suppose the relationship of special values 0 and 1 could be 2 characteristics, and the relationship to 0 negative values and values greater than 1 could be tested as other blocks of our partitioning model. But this partitioning is only valid for integer values. If we consider negative values, this partitioning is not valid, because we could not consider any value between 0 and 1. Or we cannot consider any value in this scope between 0 and 1. The values which are less than 0 is considered in this block, the 0 value is considered in this block, the 1 value is considered in this block, and the values greater than 1 are considered in block B1, but values between 0 and 1 are not considered in any of these blocks. So the union of these blocks could not constitute our domain, all real values. So these partitions could be valued just for valid just for integer values. Please note to this item which says that complete only because inputs are integers. When the inputs are float or double values which have a floating point values, this partitioning is not valid for any parameters because the completeness property of the partitioning. Okay, so we could choose one value from each block to test the side 1 parameter. Okay, for example, we choose a value 2 for this block from this block and value 0 and 1 for these 2 blocks and -1 for this block. Test boundary conditions. These values are boundary values. As you know, the first value just less than the maximum value in this block, which is less than 0, is -1, and the minimal value in this block, the minimum value of this block, which is greater than 1, is 2. So 2 and -1 is boundary values, and we should consider boundary values as I talked in previous slide as one important strategy in selecting input data. This is for inter-based. These considerations are hold for inter-based. Interface-based partitioning, but let's see the functionality-based modeling for triangle. The first two characteristics are based on syntax, parameters, and return type, and their types. The two characteristics should be considered about the syntax of the parameters of the method, and the semantic level characterization could use the fact that the 3 integer represents a triangle. As we know, the functionality of this method, which is the detection of the type of the triangle, this could be considered as semantic level characterization. We have a mechanical characterization and or syntax-based characterizations, and we could have semantic characterization. Okay, in functionality-based modeling, we use this level of characterization more. Okay, so we could partition our domain into 4 blocks. As I said, the blocks, one block for scalene triangles, one block for isosceles triangles, and one for equilateral triangles, and one for invalid triangles. Okay, so we should design 4 test cases according to this characteristic. This characteristic is named geometric classification. According to these characteristics, which we have considered according to the knowledge of the functionality of the method. Okay, so 4 test cases, at least we should define 4 test cases to test all blocks. Each value, each combination from each block should be tested. Again, please tell me if this partitioning is a valid partitioning. As you know, something is fishy in this partitioning. Could you tell me what is the fishing point? It is, excuse me, it's about equilateral and isosceles blocks. If these 2 blocks have shared some combinations, could have some values in common. Yes, they could have some values in common, because each equilateral triangle is also an isosceles triangle, because in this type of triangle all 3 sides are the same, have the same value. In this type of triangle we need just at least 2 sides have the same values. So when all 3 sides have the same value, we say that 2 of them have the same value. So all equilateral triangles are also isosceles triangles. So the property, the disjointness property, is not held for these 2 blocks. And the intersection of these two blocks are not empty. Is not empty. Okay, so we should revise this partitioning as this partitioning. Okay, in this partitioning we consider 4 blocks of our input domain. The first one is the same as the previous partitioning. The third one and fourth is the same also, but the block B2 is redefined. The block B2 in this definition is all isosceles triangles, but not equilateral. Okay, the disjointness problem is healed by this definition. Excuse me for your time. You have an exam. I will finish my speaking soon. Let me see next slides. This slide is about selecting values for from each partition, from each block. It could be easily defined by boundary values, as I told, as a separate strategy in previous slide, or any arbitrary value from each block could be selected. For example, in functionality-based modeling in block 1, a test case is considered, such as this combination. For block B2, B3, or B4, again, suitable values are selected randomly. There is a different partitioning in this slide, which consider the characteristics of each type of triangle in isolation, and in this partitioning we have 8 blocks. We have 8 blocks because 2 blocks for each type of triangle is considered, and we have 4 types, so we have 8 blocks. And in this partitioning method, we should we should do 8 tests, each from a block. Okay. Okay, I will talk about step 4 in next session, which in which we use some criteria in input domain partitioning. So let me finish this session, and you could have enough time for your exam. I appreciate you for your attention, and have a nice day or a good night. See you next session.